Hello everyone, my name is Mohamed. I am a Java developer and maintainer of Froporec Java library. We've just released Froporec version 1.4, which features the addition of factory methods to the generated record classes. In this video, we're gonna take you through a very simple use case to show how useful these generated factory methods can be. So this is about a data object named the exam report, which has some attribute. And what is needed is to populate the attribute with values at different steps of processing. Before the introduction of records in Java, a data object will be defined as a pojo, like this one here, along with getters and setters. For the processing part, we have a business logic class where we define 3 steps of data populating. The first step is register the candidate. In that case, the candidate ID, full name, and contact info are filled up. The second step is when the candidate takes the exam, in which case the exam ID, exam content, and date are set. And the last step is the exam evaluation, where we set the values of the score decimal value and the passed Boolean flag. With the object being a pojo, we simply make use of the setter method to populate the attribute. Let's run the program to see the output. At the first step, the ID, name, and contact information are filled up, while the remaining fields all have the null values. Well, null in this case is the default value for any object in Java. So each one of those attributes being objects and not being set explicitly, by default they are initialized with the null value. At the second step in the code, as you can see, we explicitly set the exam ID, exam content, and exam date, which we find here. While the first fields we set in the previous step remain the same because we haven't touched them, but we are using the same pojo instance. But then the remaining 2 fields, score and passed, remain null because we still haven't set them yet. They are set in the latest step here, where you now see them with their values. So at this step, all of the attributes have values. So this is the typical way of data handling in all legacy Java application. Now, let's say you want to make use of the new feature of Java records introduced since Java 16, and you would like to achieve the same processing as what we just saw here with this pojo instance. Let's see how such a change is going to look like. In this package, we redefine our data object as a record. So the definition is much simpler now, with all attributes defined here as the record fields. Same with the contact info, which is now also a record. Now the business logic is where you're gonna notice a big difference compared to the use of pojos. Let's put them side by side to show that. Now, as you can see, when we handled the pojo, we only had one instance of data object, and the state of that object was modified whenever we moved from one step to the next. With records, you won't be able to do the same because Java records are meant to hold immutable data, which means there is no way you can modify a record instance so that it goes from one state to another. If you need a new state of your data object, you will have to create a new record instance with the new data you want to store. So going from the register candidate step to the submit exam, you can see that we had to create a new instance of the exam report. And because we needed the same data as in the previous step, we had to pass in that data manually. And then on the next line here, we passed in the new values. And for the remaining fields here, in this case, score and past, we don't have their values yet. So we explicitly pass the null values to those two. Same mechanism is used at the evaluate step here, where you also see the data from the previous record being passed, while the remaining fields are set with their new values. Let's quickly see if that works. Okay, so if you compare this execution to the previous one, you will see it's almost the same. Of course, the numbers cannot be the same because they are randomly generated numbers. Apart from that, all the rest of the data remains the same because we use the same data in both samples. And the mechanism is also the same, as you can see. At the first step, the remaining fields, which values are not known yet, are set to null, as we did here explicitly in the record instantiation. And same thing with the others. And at this step, all of the fields are filled with data. So we were able to reproduce the same mechanism used with produce using records. So with these code sample, we just saw two inconvenient situations here with the use of the Java records. The first inconvenience is that you cannot reuse an existing instance of record and modify it, just like we did with produce. Now, the second inconvenience is whenever we needed to populate the record instance with only partial data, like here or even here, we explicitly had to also populate all the remaining fields with default values. That also means that if we are dealing with 20 or 30 attributes, we will have to align default values for all remaining fields, and that won't look so good. You might think of adding a constant constructor in your record class definition so that you can set default values for the remaining fields in the constructor. That might work, but still gonna lead to some work whenever the structure of your record changes sometime in the near future. So these two inconveniences we just described are what Froporec helps you solve by providing factory methods. Let's see how that works, but first let's close everything. In this new package, we reused the exam report record class as it is without any changes, except for the use of the Froporec immutable annotation. The real purpose of the immutable annotation is to help generate what we qualify as fully or deeply immutable version of your record class. What that means is, if for example, in this exam report record class definition, instead of having a contact info record field, we had a contact info audio field. Let's show that quickly by changing this contact info record class into the project class. So that will be the one from this package here, that project. And let's add a main method here and create a new instance. Now when we access the instance of exam report, we will still be able to access the setters of the contact info and use them to modify the contact info data. By using the immutable annotation, you have the possibility to tell Froporec to also convert other classes, like for example the contact info audio class we have here. And then when the immutable record class is generated, you will see that the type of its contact info field will be a record class instead of a project class. Now going back to the original definition of the exam report class, what we want to show you here is that using the immutable annotation also generate a total of 7 different factory methods. 5 of them which are static, as you can see them here, while the 2 others are instance methods. When you look at the body of some of the methods, you will see that they make use of constant declarations. Those constants are nothing but string variables whose values are the names of the fields of the record. All of these constants generated by Froporec are made public and static so that you can use them from anywhere in your code. Now, let's see how all of this can be used in our exam report example. In this business logic, we will try to achieve the same data populating process we saw previously, but instead of using record instances, we will use the factory methods generated in the immutable exam report record class. At each step of data population, I kept a copy of the lines of code used in the previous example so that we can compare both. The first big difference here is, as you can see, we are no longer creating instances of exam report as we saw in the previous example. Instead, we are now creating instances of the generated immutable exam report class, generated because of the use of the immutable annotation which we just saw. And now, instead of using the typical call to the canonical constructor, as we saw before, we will now make use of the generated factory methods. At the register candidate step, where we only need to populate the candidate ID, full name, and contact info, we can make use of one of the generated static factory methods, which allows us to set the values of only the fields we are interested in. Froporec will take care of setting the rest of the fields to their default values. As a parameter to the static factory method, we pass a map object, which is composed of a key of string type, while the value is of object type. The map key stores the name of the record field, while the value stores the value for the specified record field. So here you have the candidate ID constant, which actually is the name of the field here, candidate ID, as the key. And the value in this case is the random value, just like we did in the previous scenario here. The same mechanism is used for the full name and the contact information. And then we stop there. At the next step, we only need to populate the values of exam ID, exam content, and exam date, while we also need to retain the data of the previous step. To achieve that, we will now use an overloaded version of the static factory method, which additionally to taking a map of fields name value pairs, also takes an instance of an existing immutable exam report object. So instead of reaccessing the values of the fields of the existing record instance and pass them to the new instance like we did here, we are now just passing the existing instance as the first parameter of the static factory method. And then what follows is a map object where we store the names and values of the fields we want to populate, just like we did here actually. So here what Froporec is gonna do is construct a new instance of immutable exam report And for each one of its fields, check whether the field's value is specified in the provided map. If provided, then pick up the value from the map. And if not provided, pick up the value from the provided instance. Now, at the evaluate step, we will use one of the instance factory methods to populate the two remaining fields. As we saw in the previous scenario, we needed to populate the two last fields here, while the remaining data will be the same as the previous steps. To do so, we will just call the with methods, and the one we are using here is pretty straightforward. It takes the first argument as the field name, in this case score, while the second argument is the value we want to use for the score field. So by writing this, we are telling Froporec to construct a new instance of immutable exam report and set its score field value to the value we pass in here. And then set all remaining fields to the respective values they have in the job exam instance. And because the with method always return a newly created instance, something interesting we can do here is to chain several calls to the instance methods, as you can see here. So what all of this basically means is, after setting the score field to this value here, now set the past field of the return instance to this value here. And this is basically what it looks like to use some of the generated factory methods. Let's quickly run the program to see the output. So basically we have almost the same output as the previous example, with the respective fields being initialized at the appropriate step, while the remaining ones, as you can see here, remain to their default values null. So just like we saw it in the two previous examples. Now back to the program. Just before running this program, we mentioned the possibility of chaining the factory method calls. That possibility actually allows us to combine all of these lines into a single statement. So let's try that. First, let's comment all of this and make a copy of this line right here. Now, instead of stopping right here, we will continue this statement by calling the with method and passing the map we were using at the second step here. So that will make sense because it means that after creating a new instance by calling the build with static method, then create a new instance of the same type and with the same data as the previously created instance here. But for each field specified in this map here, use the provided values from the map instead of the values from the previously created instance. And then after these two statements, we will chain the call to the two with method from the last steps here. So with some additional formatting like this, this is what chaining the factory methods is going to look like. Now, with all of this, we will have only one display method here, which in that case will be the join candidate. And then when we run our program now, you will see that now we have all of the fields populated in only one go. So that's it for the use of the factory methods in Froporec 1.4. Thank you for watching.